Hello guys, I'm Pooja Gupta and today I'm going to show my capstone project on comparison of ensemble models with the ANFIS model to predict the Parkinson's disease. As my project under the guidance of the Dr. Lincoln Mully, which is Assistant Professor of Thapar Institute of Engineering and Technology. Parkinson's disease basically is a disorder of the nervous system which affects the body movements in any individual. To predict the disease, I have executed various machine learning regression models and predict the results. And then predictive results are then compared with the ANFIS for the machine learning previously developed by the Ali. The objective of my project is to predict the motor unified Parkinson's disease rating scale, which exactly tells the disease about the patient, how much the patient is prone to that disease. For this objective, I executed the 25 machine learning regression models on the dataset. To evaluate the results, I use the correlation R square, RMSE accuracy, and the time taken parameters to apply ensemble technique on the top models. And after that, I cross validate all of the results using the validation approach and then compare with the ANFIS models results. So the tools I used in my project, that is Rattle R and MATLAB. Workflow of my project is about I take a dataset from the UCI repository, and my dataset contains the 22 features, out of which I extracted the relevant features by using the Rattle. Or my extracted feature will be the 17, and out of which one is my target attribute, which is a GPRDS score. So, as per my workflow of the data system, I trained my regression models on the 70% of the data, and the rest of the data is used for my predicting the results. That 30% what I use for my test data. This is a data description. The dataset that is collected from the UCI repository, which contains a 42% vocal data, voice data, which is captured by the expertise from the patients at a home. The main objective of the dataset is to predict the motor UPDRS score from the various voice measures. For the feature selection, I already told you I used the two Rattle tool. In this, I use the two techniques for the feature selection, which is the increase MSC and the increment node priority. I run the 25 machine learning models on the dataset, which is shown as in the screen. Or for these models, I have the accuracies like 99.38 and up to so on 49.86. And my backmarsh model gives my the correct good accuracy, that is 99.38. This is the all five models which I choose for the ensampling the results, because these are my top models which gives me a better accuracy for the prediction of the UPDRS score. I then assemble these five models by using the average method, and then overall accuracy becomes the 99.6, which is much far better than the benchmark, which is 99.38. And also I cross validate the result of my ensembled model, which gives the good results as per the accuracy term, which is 99.09, 99.32 up to so like 99.66. So I then compare my ensemble model results with the ANFIS model, that is uh, that is developed by the Ali in the MATLAB. So my ensemble model gives a much more better than results than the ANFIS model. The ANFIS model gives accuracy that is 31.30, and my ensemble model gives a 99.6, which is much more better than the ANFIS model. As per the health is concerned, the accuracy is main importance. In conclusion, I just get the data from the UCI repository for eliminating the Parkinson's disease, out of which data I use the 70% of dataset for my the training the model and 30% dataset for the testing. And then feature selection is done, and after that 25 regression models are applied on that models, and which the magmars gives the highest accuracy of the 99.38. After that, I choose top 5 models for my ensemble link model. Then I ensemble the results of that top 5 model and gives the accuracy 99.6, which is good. And then compare with the ANFIS model. So it can be concluded that the ensemble model can be more efficiently used for the Parkinson's disease when compared with the ANFIS model. This is all about my the project. Thank you.